So, welcome everybody to the class. We learned a very interesting one in the last class, that was Pythagorean theorem. How do we prove the Pythagorean theorem? Does everybody remember what is it? Okay. A square plus B square equal to C square. That's what you guys learned. Yeah. Okay. I see one more kid. Yes. So Siddharth. Same Siddharth from a different device. Yeah?
Yeah.
Oh, good. Alright. So good to see you. So we learned about the Pythagorean theorem in the last class. When we say Pythagorean theorem, it applies for a certain type of triangle called right angle triangle. So Siddharth, this is a new class, first class for you. So there are a lot of things that we will talk about which might sound new to you. What I will do is, I will send the link for where I have uploaded the video of previous classes. Just go through some of them and see if you are able to follow them. And if you are getting stuck with some concepts, let me know. Ask mommy to send me a message and I'll make sure that we revise those concepts in the coming classes. Okay?
Okay.
So this class is for all the kids from, from 6th to 8th grade. So we will learn all the concepts, math concepts from 6th to 8th grade in next 1 to 1.5 years, and we'll learn it 2-3 times. So even if you miss something today, if you're not able to follow something today, be assured that we'll come across the same concept sometime down the line. Okay? Yeah? And keep asking questions wherever you get stuck. I will try catching up in the coming classes. Okay? Alright. So we are talking about Pythagorean theorem. This is what we proved in the last class. And Pythagorean theorem applies for a right angle triangle. When I say right angle triangle, I mean a triangle with one angle is 90 degrees. So far, no confusion with that, right? Here, Pythagorean theorem says that if the sides are A, B and C, A and B are the two sides making the 90 degree angle. So A square plus B square equals C square. C is nothing but the hypotenuse or the side which is opposite to my 90 degree angle. Okay? This is what we learned. And how we proved that also what we saw in the last class. Siddharth, again I'll send you the link of the video. You can just go through it, and if you have any confusion, that's a good sign. You'll just let me know that I didn't understand that, and I'll explain that in some other way, some easier way, some way where you can follow. Okay? Alright. So what are we going to learn today? So we had started with geometry. We learned about line segment, lines, rays. Then we went to a situation where we talked about two sides. That is what made the angles. And where we learned about the acute angle, the angle which is smaller than 90 degree, the right angle where the angle is 90 degree, and the angles which are more than 90 degree. You can see my hand movement, right? I'm not doing Bharatanatyam. I'm telling you guys what are different angles. Okay, I say Bharatanatyam because my daughter learns Bharatanatyam. I see her making those hand movements. But this is not the Bharatanatyam movement. This is acute angle. See, we have two sides with an angle smaller than 90 degree. This is 90 degree or right angle. And this is more than 90 degree when both the sides are going farther from each other. That is called obtuse angle. So we learned about sides, line segment, rays. We learned about parallel lines. We learned about the angles. Now, parallel lines are two lines which never meets. The distance between both of them remains the same. That's what is parallel line. Then we learned about triangles, where we learned the types of triangles based on sides and based on angles. And that is where we learned equilateral triangle, isosceles triangle and scalene triangle. And then we learned about the triangles based on the angles. That is where we learned about three types of triangles. Acute angle triangle, where every angle is smaller than 90. Right angle triangle, when one of the angles is 90 degree. And an obtuse angle triangle, where one of the angle is more than 90 degree. Okay. Then we learned about quadrilaterals, rectangles, squares, parallelograms. Then we learn about kites, rhombus, trapezium. We learn about finding areas for rectangles, squares, and also did we find area for parallelogram? Yes, we did. Yes. So that is all we have learned so far. Today we want to start with a new concept called congruence. Have we talked about congruence in the past? No? Okay, that's good. So for all the kids who are in the class for the first time or have joined recently, I don't teach math. I don't try teaching math in a way that it looks like math. I try teaching math in a way where you can relate math with what you do with the things around you. Okay? So that's what I'll keep on doing. So when I talk about congruence, now let's look at me. I'm again doing one more dance step. Look at this. What do you see? What do you see right now? Two hands? Yeah? What do you see now? One hand? Everybody here, pay attention. What do you see? One hand? What do you see? Still one hand? Imagine my hands were not same. Let's say if my one hand was distorted or bigger than the other one, how it would have looked? Like this or like this? Not like one hand as before. So the situation like this, where both the hands are completely hiding each other, completely overlaying each other, and regardless of which side you are looking at it, it looks exactly the same as one hand. This is called congruence. When both my hands are same. You buy two shoes. One shoe is bigger and one shoe is smaller. That is not congruent. You probably got somebody else's shoe then. Yeah? Similarly, if you come back to the shapes. Come back to the shapes. I am talking about this triangle and this triangle. By any means, will they ever be congruent? The two triangles that you see on the board. No. They will never be congruent. If I put this triangle behind this triangle, I will see one triangle. That is okay. It might give a feeling that it's congruent. But if I put this triangle behind this triangle, meaning if I put this smaller triangle behind this triangle, it will look like one triangle. As soon as I put it here, I can see two triangles actually. These are not congruent. So when we say congruent, in simple or layman's term, you are saying that it is exactly the same. Everyone. Everyone is trying to find congruence through a binocular, huh? Okay. Alright. No. So sometimes I'll keep on waking you guys up with some what do you call, silly jokes, but that's okay. Don't take it personally. Now, when I have let's say two triangles, and I say these are congruent, what I mean is all the sides. If this is one side of the triangle, there is a corresponding matching side to this triangle. This is my second side. There is a corresponding matching side. If this is my third side, there is a corresponding matching side. Meaning, length of this side and this side will be same. Length of this side will be same. Length of this side and this side will be same. And also, this angle and this angle will be same. This angle and this angle will be same. This angle and this angle will be same. So what I am saying is, whenever you come across a situation where somebody says two triangles are congruent, that means you are saying that each and every property of the two triangles are matching. Yeah? What are my properties? I have two hands, I wear glasses, Many a times I take my glasses out for seeing something close. I have two legs. I am this tall. These are my properties, right? Likewise, if you look at any shape, this also has certain properties. These sides are its properties. These angles are its properties. Okay? So when we say two triangles are congruent, what we are essentially saying is each and every property has a corresponding match in the other triangle. So far so good? Anything sounding confusing? No? Anything you want me to repeat? Siddharth, this is your first class. You can ask as many questions you want. And again, regardless of whether it's your first class or not, for everybody in this group, everybody in this class, if you have smallest of the doubt, don't hesitate. I am not a scary looking teacher and I try my best not to look scary, okay? So, if you have any doubt, just raise your hand and ask questions. Okay? And if you are asking unnecessary questions, I will stop you. That's okay. But don't stop yourself from asking questions. Okay? Alright. So now here, so far what we have seen is, when I am saying two triangles are congruent, what I am saying is they have exactly matching properties. Okay? I will never be congruent to a cow. Okay? I can be congruent to a human being because human beings have similar properties like me. Cows have 4 feet. I will never have 4 feet. So I will not be congruent to a cow. So same way here also, you will find triangles being congruent to triangles. Triangles will never be congruent to a rectangle or a square or any other shape which has different dimensions. Yeah? I know it's not a great example, but still something that helps you remember it. Okay. So now, whenever you come across a situation which says the two triangles are congruent, meaning every property in one triangle has a corresponding matching property in the other triangle. Simple, right? If you say 3 triangles are congruent, meaning each of the 3 triangles have matching property. One side here has a matching side here and here. Second side here has a matching side here and here. Okay? So congruent means same. That's how I'll put it. Okay? Everything is same. Clear? Now let's look at next step beyond congruence. Can the rectangles also be congruent? Can the rectangles be congruent as well? Anything can be congruent. If I can be congruent with a human being, I am a 3-dimensional object. These are 2-dimensional objects. They can always be congruent. Whenever there is a property matching, it will be congruent. Okay? Alright. Now, let's look at some of the mathematical parts. So far we have looked at only the practical side of things. Now when we talk about congruence, let's start with the congruence of triangles. Okay? There are 4 theorems. They are called SSS, SAS, ASA and RSS. These are 4 theorems. They might be looking very cryptic, complicated, but they are not. They are very cute theorems. Okay? Now, these are the theorems that tells you that if certain properties are matching, let's say you have to look at 2 triangles, whether they are congruent or not. How will you prove it? There has to be some mathematical way of proving it, right? So these are your tools or your enablers which will help you prove the congruence. You don't have to match each and every property. You use one of the theorems to prove it. Okay? Now let's look at what are these theorems. Any questions so far? No? So congruence, we know it's, when we say congruence, we're talking about 2 things or multiple things being exactly the same. Okay? That is what is congruence. Never ever say 2 of my neighbors are congruent. I mean, we don't use that in practical life. We will we'll use that more with respect to the shape that we deal with, okay? We'll not make our neighbors congruent, okay? So when I said that I am congruent, I'm going to be congruent with another person, that was just an analogy, not a relatable thing in real life. But we'll keep focus on two-dimensional shapes, like what we want to learn. So we are talking about congruence of triangles. There are 4 theorems. One is called SSS, meaning if the 3 sides of 2 triangles are same, they are congruent. Meaning if this side is matching with this side is matching with this side, and this side is matching with this side, these two are congruent. Side, side, side. If all the 3 sides are matching, they'll be congruent. Now let me give you guys an interesting problem. Let's say I'm giving you 5, 6 and 8. 5 centimeter, 6 centimeter, 8 centimeter. Draw a triangle. Draw 2 triangles with this dimension. One side is 5 centimeter, one side is 6 centimeter, one side is 8 centimeter. Draw 2 triangles with this dimension. Can you?
You can't.
Why so?
Because they're all in different. They're in order.
Now you're thinking in the right direction, Pranav. I'm just wanting to this is not the right example. It's like I'm trying to suck all the knowledge that you have, okay? So tell me, you're going the right direction, okay? When you have these 3 dimensions, 5, 6 and 8 centimeter, or any combination of dimension, okay? Can you draw 2 triangles with the same dimension? Probably not. You can draw only one triangle. Only one triangle with the 3 dimensions. I mean, you can play with it. You can, let's say 5, 6 and 8. Let's say this is 8, this is 5 and this is 6. This is 8 centimeter, this is 5 centimeter, this is 6 centimeter. Okay? I can flip it. I can say, okay, I will make 6 as base. I can flip this by 90 degrees. Okay? And then 6 becomes my display. And this. So this is 5, this is 6 centimeter, and this is 8 centimeter. So, yeah, so you can flip it, but it will be the same triangle actually. You are just changing the alignment of the triangle. That's it. If you have 3 dimensions given, you can draw only one triangle actually. Even if you draw 3, 4, 5 triangles, they'll be exactly the same. You have just probably flipped them or placed them in a different place. That's it. Okay? Now, so the first theorem says that if you have 2 triangles with 3 sides matching, they are congruent. That's what I was telling you guys. That if there are 2 triangles with the matching dimension, meaning the 3 sides being the same, there will be only one triangle actually. So they are congruent, meaning you can literally overlay one over the other one. Okay? That is how they are congruent. And if they are congruent, that means you will say this angle and this angle will be the same, this angle will be the same, and this angle will be the same. So here from this theorem, what we are saying is, you don't have to match all the properties of 2 triangles for them to be congruent. Even if only 3 sides are matching, that is more than enough. Then you can assume that other dimensions, other properties will be the same. Let's look at one sum. Okay? Let's say the kind of questions that you guys will come across. Say this triangle is 5. This is 5 centimeter, 8 centimeter, 12 centimeter, and this is 5 centimeter, 8 centimeter, 12 centimeter. This is 80 degree, this is 20 degree. Okay. Now find out the value of the remaining angles. This is 20 degree, this is 80 degree. Now look at this triangle, 5, 8 and 12, 5 and 12. Say this is 20 degree, this is 80 degree. Find out the value of this angle, find out the value of this angle, find out the value of this angle, find out the value of this angle. Nobody said anything else. You have only 3 sides matching here. Yes. Sherry is saying something. Yes, beta.
For the angle is
80 degree, 20, 80, this is 80 degree, okay? How about these angles?
those angles are
I'm sorry? Let me change this video. Yeah. Now tell me the angles. How much will be this one? How much will be this one? How much will be this one? So let's call this is 1, okay? This is 2 and this is 3. Tell me how much is 1, how much is 2, how much is 1, how much is 2, how much is 3. Okay? Let's see who wants to go next. Somebody was raising hand. Amoga, Sanvi, Dikshita, Pranav, Divan, anybody? Siddharth, Sagarika. Okay, let's see what Amoga has to say. Yes, Amoga. They are congruent triangles. That's your first observation, right? When you look at this triangle and this triangle has one side is 5 centimeter, this has 5 centimeter. This has one side 8 centimeter, this also has one side with 8 centimeter. This has 12 centimeter, this also has 12 centimeter. I was kind of tricking you guys, okay? I just changed the position, okay, so that you don't say 80, 20, 80, 80, 20, 80. No, not like that. I just changed the position of one side, okay? They are exactly the same, I have just flipped the triangle. Now I want to know how much is the value. So both the triangles are congruent now, for sure, because sides are matching. Now I want to know the angles.
I think that angles will be same as the other.
Sorry, beta, say that again.
I think that it will be same as the other.
Angle will be the same as the other one, but I have already tricked you guys a little bit. So that's why I want to know how much is 1. Let's say 1. This is 1. Tell me how much is the value of 1.
80.
You are saying 1 is 80. This is 1 and 80 degree. Between 5 and 8. 5 and 12. No, that is wrong. Okay, any other guess? I'll tell you why. Because I was tricking you guys, right? That's why I know why it is wrong. Okay, Amoga, Vivan, how much it is?
Is it 20?
Now say with confidence, don't say is it 20. If you say think 20, say 20. 20. See, never doubt yourself. Okay? That's the most important thing. If you know it wrong, let it be wrong. You say it is 20 and you have a reason for 20, okay? And that's not only for Amoga, for everybody. Okay, Vivan, what was your answer?
I was going to put center.
I'm sorry?
I was going to put center.
20?
Yes.
And your answer has never, it never has to be, is it 20? You will say 20, it is 20. Now, let me flip this question a little bit. So, Amoga, tell me why you think it will be 20? Why not 80?
Because it lets the first measurements.
Okay, that's one answer. What could be another way of saying the same thing? In a more mathematical way.
The angle is like
Hmm?
the angles are.
Okay, I know that you guys know it. You are not able to articulate that's where I'm trying to, again, I'm forcing you guys to say something that I want to listen. Okay? Let's say what we want us to say. Yeah, we want.
The reason how I got 40 is
Uh-huh.
5 is matching with 12 and the answer is sorry, the angle is different. And if you flip the triangle, the answer is different.
Okay. I think you all know this, okay? I'm just and you were going in the right direction. We want. Simple way would be, we identify the angle by the sides making it. We identify the angle by the sides making that angle, okay? There is no angle without a side. There are two sides. They come, join each other and make the angle, right? Here, look at this 20 degree. 20 degree is made between line 5 and 12. If these two triangles are congruent, then angle between 5 and 12 will be the same. That is how you will recognize them. I might be a bad guy, I might roll it like a dice and it flips 5-7 times. And that might become an issue with visualization. What you will do is, regardless of how many times you roll it or you flip it, your position of 5 and 12 will not change. So the angle between that will not change. So 5 and 12 is 20 degree. Here 5 and 12, 20 degree. This will be 20 degree. 5 and 12. See, the angle is made between 5 and 12. 5 and 12. If these two triangles we have proved congruent, meaning the angle between the sides will be same. Now tell me how much will be number 2? AD. Now you don't have a choice. Both the remaining angles will be 80 only, right? But again, if it was not 80, your argument would be that this will be 80, number 2 will be 80 because this is angle between 5 and 8. And 5 and 8 is 80, so that's why it is 80. Okay? 5 and 8 meaning the side making 5 and 8 centimeters. Yeah? And this is something that you would have noticed, right? When we talked about how to prove the Pythagorean theorem, there also we saw that if I have a triangle, I'm recognizing the side which is opposite to the angle, right? The similar triangle thing that we looked at, right? You always relate the angles or sides in relation to how they are aligned, how they are placed against whom. Yeah? Same thing here. So if these two triangles are congruent, then it means your angles are matching. So the question that might come in the exam for you will be, okay, these are two triangles, like I was giving you guys the sides, that was the clue that these two are congruent, and I gave you guys one angle, two angles, you have to find out what is the third angle, and then find out what is the corresponding angle here, so that you can match the value. Okay? Alright. So this is on the first one, SSS. And trust me, you can always prove all these theorems also. We are not doing that right now. We'll probably do that when you guys are closer to getting to level 3. Okay? So right now, just focus on the outcome part. We'll talk about it. Okay? So first is SSS, meaning the three sides of two triangles being same makes them congruent. And once they are congruent, everything else matters. Yeah? I will not move on unless I hear a confident yes. Okay. Alright. Now let's look at the second theorem, which says SAS. Simple, for sake of simplicity, S stands for side, A stands for angle. And all these theorems are for triangle. So first one we looked at SSS, side, side, side. Now we are talking about side, angle, side. This is one triangle. This is another triangle. This time, the question doesn't tell you that these sides are matching. What it says, Oh, this side is 12 centimeter. This is 18 centimeter. And this is 40 degree. This is 12 centimeter. This is 18 centimeter. This is 40 degree. Side, angle, side. Side, angle, side. Side, angle, side. If there are two triangles where one pair of sides and the angle between them match, these two triangles are congruent. That's the theorem. Now you will say how? I can give you a little bit of clue here, okay? See, this one, we saw that when you use three sides, you can draw only one triangle. You can flip it, but it will not be different. Here also, look at this. I have, let's say, two sides, 12 centimeter and 18 centimeter. I made 40 degree angle. I use the same sides. This time I made 90 degree angle. Okay. Now I have the same side. 18 centimeter, 12 centimeter. I made 120 degree angle. Now look at this guy. This guy. What do you see here? AB is smaller than CD and CD is smaller than EF. Do you guys agree? Based on what you see on the board? And do you know why? Why AB is smaller? AB is smaller than CD and CD is smaller than EF? Why? Do you know what is the reason? Who is the culprit? This angle is the culprit. Angle between the line is making this AB, CD and EF bigger or smaller. Yeah? Smaller the angle, smaller the line. Got bigger, line got bigger. The end points, right? We are correcting the end points of the line segment. Angle became even bigger. The end points got further away from each other. Yeah? So what it means is, the smaller the angle, the end points are closer. Bigger the angle, end points are farther. Even bigger the angles, end points are even farther. Same the angle. Same the angle. End points will be same distance. Yeah? Are you guys with me? Am I making you guys scratch your head? No? Okay. If I do so, just let me know. It's okay. So here, in these two triangles, what's happening is, these two sides are fixed. These two sides are fixed. Angle is also fixed, meaning the distance between these two will be fixed. If the angle was bigger, the distance would have been bigger. Angle was smaller, the distance would have been less. Here, both angles are same. That means this distance here to here and this distance is same. Making sense? Is it? Yeah? Don't have to say just for making me happy, it's okay. Okay. So now if you look at this side and this side are same, this side and this side are same, and just because the angle was same, even this side are same. It became SSS. Yeah? The three sides match. So that is congruent now. So even if you are given two triangles with two sides being same and the angle between them being same, that is congruent. And that is what this theorem says. Yeah? Are you guys with me so far? So let's see who joined after I started. I see Gitesh has joined and Siddharth is there. Okay. Let me do a quick roll call. I see Dikshita is fine. Gitesh is there. Jaya Reddy. Is that? Am I missing somebody? Okay. I just want to make sure that I know the students. Okay. Okay. Siddharth is there. Pranav is there. Sagrika is there. Then Amuga is there. And then Sanvi is there. So only person whom I'm not able to recognize is Jaya Reddy. Oh, that is Cherry. Oh, my bad. Again. So that's my bad. So yeah, I was just making sure that I'm not missing anybody here. So Gitesh, since you joined late today, just a quick recap of what we have done so far. Okay? Can you hear me okay?
Yes.
So today we are talking about congruence. When you say congruence, meaning something being exactly the same, like the size of our feet, both the legs, both the hands, same. So we tried relating that concept with the different shapes that we know about. When I say two triangles are congruent, meaning they are exactly the same, they can literally overlay each other. So, and when two triangles are congruent, or any two shapes are congruent, that means they have all the properties matching. So if you recall, when we started learning geometry, what we did was, we looked at each and every triangle, every shape's properties first. Triangle has properties like sides and angles. Rectangles have properties, same thing, sides and angles. They have 4 sides, 4 angles. If we ever come across a situation where we have to say that the two rectangles are congruent, that means they will have all 4 sides matching among them and 4 angles also matching among them. Okay? So anything, if we ever say any shape is congruent, we simply mean that each and every property of the shapes are matching. That is when they are congruent. So based on that understanding, we continued further and we looked at some of the theorems for congruence. We started with triangles. So the first theorem for congruence is SSS, side, side, side. Meaning, if there are two triangles, side by side, where every side has a corresponding matching side in the other triangle, these two triangles will be congruent. Okay? And we tried proving that with some argument. When you watch the video, you'll be able to recap on that. Second theorem is SAS, meaning when two sides of two triangles are matching and the angle between them is also same, then the triangle will be congruent. And that is where we saw this thing, that when you have two sides and the angle 40 degrees, this is the distance. When this is 90 degrees, this got little far from each other, even if the sides are same. So the distance between the two edges of this side is a function of how big or small the angle is. If the angles are same, that means this distance will be the same. And then we see that this side is matching with this one, this is matching with this one, and this one is also matching with this one because of this property that we saw. So these sides are matching, so this is also congruent. So SAS is also another theorem for congruence. That's what we saw. Any questions so far? Anybody? No? Okay. Alright. So let's move on. So we again doing a recap. We have looked at two theorems for congruence, SSS and SAS. So let's not overburden ourselves with a lot of theorems in one day. Let's play with some sums. Now, let me give you guys some sums. Or let's practice with two problems. If you guys know anybody teaching drawing skills, let me know. I would want to join one. My drawing skills are not great. Okay? Now these are two triangles. I am saying that they are congruent. Why did I say that? This is 30 degree. This is 85 degree. Okay? This is 8 centimeter. This is 12 centimeter. This is 55 degree. This is 30 degree. Okay. Find out the missing angles between the two triangles. So I have this triangle and this triangle, okay? This is 8 and 12, this is 85. This is 8 and 12, this is 30, 65. I don't know how much it is. I want to find out the value of this angle, this angle. And the only clue that, okay, yeah, Vivan is ready.
For the first, I believe it's 65.
How much?
And for the second one, I believe it's 30.
This one you said how much?
The first one is 65.
65. Okay.
And the second 30.
How much? How much is this one?
It's 30.
30.
Wait, sir. I can see the one up.
This is 65, this is 30.
Oh, then it's 80. It's 85.
Okay. And let's see how much Dikshita has to say.
I think the first triangle is 65 and the second one is 85.
Okay. So you both have got the same answer, okay? Anybody having a different answer? And that is what I call as unity and diversity. If you have some different answer, I would love that. Okay? Let's see if anybody gets a different answer. Is everybody able to solve it first of all? Okay? Do you guys, okay, now here comes flipping tables. Now I want one of you to explain me how did you go about solving it? Okay. I'll give chance to somebody else who has not showed the answer. So Vivan and Dikshita were quick in giving the answer. I want to see if anybody else can explain me, I mean can teach me. Let's say it's like a sum that is given to you and you're trying to explain me. I was not getting it.
I don't think we solved it. I don't know how. I'm not getting answers.
Okay. So that's fine. So if you're not getting it, that is when we have an opportunity. We certainly want. Okay, let Amoga teach it to you and me both. Okay? Amoga, why don't you go ahead and explain?
Sir, if you want the 65
Sorry, say that again.
sir, if you want the
Yes, I want you to explain what did go in your mind for solving it.
I can't hear you.
No, I'm saying I want you to explain what did go in your mind to solve it.
Like, when how I solve.
Yeah, how did you solve?
So one that the first one had the angle 30 degrees and 30 degrees. And then the second one,
Okay. So you knew that one of the angle is 30 degree and you knew the second angle was 85 degree. So sum of all the angles of a triangle is 180 degree and we have two angles 30 and 85. So 30 plus 85 plus something equals 180. So this gives me 30 plus 85 is 115 degrees plus C gives me 180 degrees. That means the value of this angle which we don't know will be equal to 180 minus 115. That is how we got 65 degrees. Okay? I'm just slipping on your behalf in a way to explain, okay? So that kids who were wanting to kind of redo that, Sarvika, that is making sense, whatever we are doing so far. So first one is solved. So this one we had not used the theorem of congruence, okay? How about the second one? So you got this as 65. Done. What did you do next? Yeah, Mughal, continue. What did you do next for this one?
so then I did 65, and then 65, and is that 80?
This is 8.
No, the angle.
Angle 65 and 30.
So then I did 65 plus 30.
And I did not give this 65 actually. I have given only 8 and 12.
Okay. So and 12. With
No, I think that not be enough. That not be enough. I have to give this. Yeah. What I can do is that fine. Now okay. Yeah, go ahead, solve it. Yeah. So again same thing here, right? There are three angles together, 180 degree. Two angles are given. Subtract this from 180 and then you got the third one, okay? So if I would have not given this as 12, you could have used, okay fine. This angle is what? This is coming to 85. And now if this side was not given, you had a way to find out the length of the side. But that we will be able to do only after we do this one, okay? So far we have not done this one, so you will not be able to find out this side, okay? But angles you will be able to find out. Now, okay, so we have, let's say 5 more minutes. We looked at two theorems. One is called SSS and second one is called SAS. So S stands for side, A stands for angle. So these are the theorem for congruence of triangles. First theorem says, SSS says, if there are two triangles with sides matching, they will be congruent and every other property will match if they are proven congruent. Second one is, it says SAS, meaning if there are two triangles with two sides matching and the angle between them also matching, the whole triangle will be congruent. Okay? So that is how we looked at the second theorem. Then comes the third theorem, ASA, and the fourth one is RHS. These two theorems will part for tomorrow. We'll learn these tomorrow. But before that, there is one magical formula that I want to know if you guys are aware. If I ask you guys, I have a polygon. I have a polygon with 10 sides. If I have a polygon with 10 sides, with 10 sides. What will be the sum of all the angles within that? Okay. Polygon means something which has multiple sides. So a triangle is also a polygon, a rectangle is also a polygon, a trapezium is also a polygon, a pentagon is also a polygon, a hexagon is also a polygon, so on and so forth. Yep. Everybody with me so far? If it's a triangle, we know the sum of all the angles is how much? 180 degrees. Yep. If it's a rectangle, we know sum of all the angles is what? 360 degrees. Be it a rectangle, be it a trapezium, be it a square, be it even a kite, all quadrilaterals, sum of all the angles is 360 degrees. I am saying, I have a polygon with 10 sides. Tell me what is the sum of all the angles. Or I might change my mind, say, okay, how about a polygon with 20 sides? Tell me what is the sum of all the angles. There is one magical formula that gives you the answer for any polygon. You just put the number of sides, it tells you what the total angle would be. That's why I call it the magical formula. 10 sides. So what is the formula? It says 2n minus 4 into 90 degrees. Here n is the number of sides. I said 10 sides. Put n equals to 10 minus 4. 2n minus 4 into 90 degrees. 2 into 10 is 20 minus 4 into 90 degrees. This equals 20 minus 4 is 16 into 90 degrees. This equals 16 into 9, 144, 1440. This is my answer. It's all about just knowing this formula. 2n minus 4 into 90 degrees. That gives you the sum of all the angles inside that polygon. Now, if you want to validate this, we are talking about this being a generic formula for all the closed shapes, all polygons. Let's look at triangle. Triangle has how many sides? 3 sides. 2n minus 4 into 90. N is 3. 2 into n. Triangle has 3 sides. That's what I am putting here. Into 90 degrees. 2 into 3 is 6. Minus 4 is 2. Into 90 degrees. Yeah. So triangle, sum of all the angles inside a triangle is 180 degrees. That can be proved by this theorem, this formula also. Now, you all know that any quadrilateral or even a rectangle for that matter, sum of all the angles is 360 degrees. Can I use this formula to see if this is correct? Number of sides in a quadrilateral is 4. Minus 4. 2n minus 4 into 90 degrees. 2 into 4 is 8. Minus 4 into 90 degrees. 8 minus 4 is 4 into 90 degrees. Yeah. So this 2n minus 4 into 90 becomes a magical formula for getting the sum of all the angles inside any polygon. Whether it's a pentagon, hexagon, heptagon, octagon, nanogon, everybody gone. Multiply the number of sides with 2 into n. N is the number of sides, minus 4 in the bracket, multiply by 90. And that's the answer. Alright? That's what brings us to the end of the class. Just to do a recap, what all did we do? We learned about congruence. We learned 2 of the theorems for congruence, SSS and SAS. Then we learned the magical formula for knowing the sum of all the angles inside any polygon. So tomorrow if you come across a question, you can go and challenge somebody, okay? You can just handpick anybody in your friend circle and say, okay, you have 15 sides in a polygon. Find out the sum of all the angles inside the polygon. Let's see if you get the answer or not. Yeah? Play with math. Fight with math. Enjoy math. You will love math. Okay? Yep. That brings us to the end of the class.